On to the next problem. We're dealing with this vertical train. So that means we're dealing with mass, acceleration due to gravity, all of that stuff. So we have 3 blocks being lifted, so they have an initial upward speed. Okay, so our upward speed is 10 meters per second. Let's make a note of that. 10 meters per second. The blocks uniformly slow down to rest. I know rest always tells me I have a 0 velocity somewhere. Over the course of 2 seconds. Oh, look at that. 3 variables. 3 variables. Looks like it's uniformly slowing down, which means a constant acceleration. We can use kinematics here. I don't know if we need to. Let's continue on. Answer all of the following for the time during which the blocks slow down. All right, blocks, free body diagrams showing the forces on each of the 3 blocks. Oh, I made a note of my velocity going up. I should also mention the acceleration's going down because we are slowing down, just in case we need it. All right, what else? Forces on the 6 kilogram block. That's this guy right here. So we know the weight force going down. So that's 6 times G. And then we have TC going up. On the 10 kilogram block, pulling up is TB. Pulling down is the weight of the 10 and the weight of the 6. So we can do a combined mass. So it would be, if we call this M1, M2, M3, then this would be M3 times G, and this would be M2 plus M3 times G. Over here we have the forces on the 4 kilogram block. So that is going to be all 3 masses. So I'm just going to call that my total mass times acceleration due to gravity, and then going up is TA. It says 8 total arrows, and I suppose we would have 8 total arrows if I had 2 going here and then 2 going here. That's fine. It's okay. This is going to help us with our problem solving. It's kind of a shortcut. It's going to make things a little bit cleaner and easier. So we're going to do that. Use the equations to find the 3 tensions A, B, and C. Oh, we didn't write equations. Mr. Scopetis. The very next step after drawing free body diagrams is to write your equations. So let's get to it. Writing our first equation, and I'm going to go ahead and solve for the tension here, just because. So we have stuff that makes it go. We're going up. So we have TC minus holding it back, M2, M3G equals M3 times acceleration. How fast is this going up? Well, 3 blocks are being lifted. Uniform acceleration, I already said that. That means we can use a kinematic equation. If we have initial velocity, final velocity, and time, velocity as a function of time. So that's going to be Vf minus V naught. Let me start with the first equation. Sorry, I'm rushing ahead. Vf equals V naught plus At. Rearranging that, I get my acceleration to be Vf minus V naught over T. Vf is 0, initial velocity is 10, so negative 10 divided by 2, that equals a negative 5. Negative 5 meters per second squared. All right, we've got our number. We can come back on over to this equation. Solving for TC, I'm going to add all of this stuff over here, M3G over here. And at this point, we can go ahead and plug in our numbers. M3 is 6 times acceleration is negative 5, so we have negative 30 plus 60. So TC equals 30 newtons. Good. I'll make a note of that over there because I'm going to erase that because I need more room. Solving for TB. Let's do it. Stuff that makes it go. TB minus all of this junk right here, which I will just call FW, equals mass times acceleration. and this is mass 2 and 3, don't forget. So I add my weight force over here, and I get T equals this combined mass of 2 and 3 times my acceleration plus that weight force up there. So again, let's go ahead and substitute in our numbers. So mass 2 and 3 is 16 times my acceleration, which is -5. So 16 times -5 will give me -80. And we have my weight force, which is 16 times 10, 160. So TB must equal 80 newtons. Moving right along. TB equals 80 newtons. What do you think? Is TA going to be larger or smaller? You already know. Stuff that makes it go minus stuff that holds it back. Total mass times G equals mass total times my acceleration. My total mass is 20 times -5 is going to be -100. Adding the total mass times acceleration due to gravity is 200. TA will then equal 100 newtons. So TA has to be the strongest, has to have the most tension in it, and I think just by looking at it, it's pretty obvious that you have more mass, you have more stuff pulling down. So of course the tension is going to be greater at the top.